Hello, my name is Mr. Bryce with Susquehanna Valley High School here in Conklin, New York, and we're doing Unit 4, Lesson 2. If you don't understand what I'm saying, you can scan this when you have the worksheet, and the person who wrote the worksheet can explain it to you. So what we're going to be talking about is rational exponents. When you first learned about exponents, they were always positive integers, okay, like 5 squared, 6 squared, 7 squared, 2 cubed, and just represent repeated multiplication. And then we had to go on and introduce negative exponents. That just means bring it to the opposite side of the fraction bar and then do what the exponent said. So today, we'll introduce a rational or fractional exponent. That's where the exponent is a fraction, not the base, like with the negative exponent, but with a fractional exponent, that's where the exponent itself is a fraction. So what we're going to talk about here is recall the product property of exponents. So recall that the fact this is the product property, or what they're calling the product property, which I really don't like the name, but that's what we call it. There's no need to find an actual number here. We just want to write it as an exponent form. Remember, this is 2 cubed times 2 cubed times 2 cubed times 2 cubed. Wait a minute. So what they're calling is the product property is the fact that instead of doing that, we just do 2 and then 3 times 4. Wait, I thought we added them. No, this says write down 2 cubed 4 times. Okay, so that's 2 to the 12th. Okay, that's really long way around it. This one, there are 2 right answers. You can multiply the 5 and the negative 2, so it's 5 to the negative 10th. Or if I tell you to write it with a positive exponent, it's 1 over 5 to the 10th. Both of these are correct. This one, I just want you to engage the brain. Just want you to engage the brain. House to the 0 power equals 1. It doesn't matter what's inside the house as long as it's not a 0. As long as it's not a 0, anything to the 0 power equals 1. So here, anything to the 0 power, because that is not 0, anything to the 0 power, that is 0, equals 1. Okay, now I'm going to take this in stages, and you're going to take it in stages too. So just do inside out. So that's 4 to the negative 4th, and then square it. Inside out. 4 to the negative 8th. Why? Because I multiplied 2 and negative 4. Another right answer is 1 over 4 to the 8th. If you have any questions, make sure to ask me. We're now going to look at the product property, extend our understanding of exponents to include unit fractions exponents. Okay, those in the form of, so we're going to have fractions. Like I said about a minute ago, we're going to use fractions as exponents. So what's going on here? Consider the expression 16 to the 1/2. I know you know the answer to this. Just humor me. Apply the product property to simplify. Okay, I just said what the product property was up there, right? So let's take a look at this. 16 to the 1/2 times 2. Right? We just multiplied these. We just multiplied these. We just multiplied 3 times 4 to get 12. So now we're just doing 1/2 times 2. Well, what is that? Half of 2, half of 2. Oh, yeah, that's just 1. Okay. So now, apply the product property to simplify. What other number squared yields 16? So let me see. This is saying what number squared is 16? Let me see. What number squared is 16? Oh, yeah, that's right. Negative 4 times negative 4 is 16. Interesting. So let's think about this a little more. Let's take a look at that and say multiplication is commutative. We could change the order. 16 squared to the 1/2 power is also 16. I mean, you know what 16 squared is, right? 196. Wow, 196 to the 1/2 power is 16. Huh, 196 to the... Okay, now, originally, this up here is saying, let me see, 16 to the 1/2 power, and then we're going to square it. And we're going to get 16. How in the world are we going to do something to a number and then we're going to get that same number out? Must be the identity property, or inverses. They're inverses of each other. You can now say that 16 to the 1/2 is equivalent to what familiar quantity? They're inverses of each other. Remember, I just said here, over here on the left-hand side, I just said here, we're inversing a square. What's the inverse of a square? A square root. So anything to the 1/2, x to the 1/2 is the same as the square root of x. Important idea. This is remarkable. An exponent of 1/2 is equivalent to the square root of a number. Woohoo! Let's test the equivalent of 1/2 of an exponent in your calculator. Okay. I am not going to give you the answer. 25 to the 1/2 power equals what? I am not going to give you the answer. 81 to the 1/2 power equals what? Okay, I lied. I am going to give you the answer. I'm going to show you how to do it on the calculator. Just in case you didn't get the first one right, no reason to get you 2 questions wrong in a row. So this is asking you for 81 to the 1/2 power. 81 caret. Now, you might have to put it in parentheses. 1 divided by 2. You might not. Depends on which addition you have. This one, you didn't have to. And there we go. It's 9. And 100 to the 1/2 power? So, for any given positive integer, this is true. Wait a minute, what does that mean? Well, simply, x to the 1/3 power is the cubed root of x. On the next page, rewrite each of the following using, instead of a fractional exponent, rewrite each of the following using roots instead of a fractional exponent. Then, if necessary, evaluate using your calculator to guess and check to find the roots. Really? Yeah. Guess and check? I don't think so. No guessing. This is the cubed root of 125. We used a root instead of a fractional exponent. I hope we know. 5 times 5 is 25. 25 times 5 is 125. So the cubed root, what number times what number times what number equals 125? 5. There's a big clue there, a number ending in a 5. 16 to the 1/4. I know what the square root of 16 is. It's 4. Oh, wait, and the square root of 4 is 2. So I'll bet you 2 times 2 times 2 times 2 is 16. One over 9 to the 1/2. That's not how we write it. 1 over the square root of 9. Okay, now, normally we'd have to rationalize this, but we know what the square root of 9 is. 1 over 32 to the positive 1/5 now. Now let me see, I remembered that 2 to the 4th is 16, and 16 times 2 is 32. Oh, sorry, had to write it as a, there we go. Had to write this one as that. Okay. Very straightforward. We can now combine traditional integer powers with unit fractions in order to interpret any exponent that's a rational number. In other words, a fraction. The next exercise, we're going to illustrate this thinking. Remember, we want our exponent properties to be consistent with the structure of the expression. Let's think about this. Something like 4 to the 3/2 power. Okay. So this is what I want you to think of. 3/2 equals what fraction times a half? Okay, let me see. So 1 times what equals 3? 3. 2 times what equals 2? 1. 3/1. Okay, so that doesn't go there. Sorry about that. 4 to the 3/1, because we're just talking about the exponents there. The base still stayed the same as a 4. So do I know what 3/1 is? Yes, it's just 3. So this is 4 cubed to the 1/2 power. Fill in the missing blank, then evaluate. Evaluate means find the numerical answer. 4 times 4 is 16 times 4 is 64. 64 to the 1/2 power. Remember, the 1/2 power just means square root of 64, which is 8. Fill in the missing blank, then evaluate the expression. 4 is the base. Let me see. Is there some kind of rule? That might be just the numerator. And so we're just left with 1/2. Okay. Okay. The square root of 4 is 2. And 2 cubed is 8. Now listen, I'm explaining things. I'm right here. If I'm not here, then come on down during a study hall. Come on, just wait for class. If you happen to be doing this at home, ask me in class. Ask me questions. Don't be shy. Evaluate. 27 to the 3/2 without your calculator. Show your thinking. Verify with your calculations. Okay, let me see. What was I doing? I was taking 27 and I was keeping the denominator, the bottom, 1/3. And then the numerator came outside, not as a fraction, just as a 2. 27. What number times what number times what number is 27? Oh, yeah. 3 times 3 times 3. 3 times 9 is 27. So it's the cubed root. The cubed root of 27 is 3. I'm going to draw an arrow there instead of an equal sign. And then we have to square it. 3 squared is 9. Final answer is 9. These are all odd numbers, okay? I mean, the roots are all odd numbers. Something special when they're even numbers. We might have more than one answer. For a rational number, m divided by n, we defined any number b is the base, m raised m to the n, to be simply the bottom number, the numerator, goes on the top, inside the radicand, and then b to the m. We're wrapping it up here. Evaluate each of the following exponential expressions involving a rational exponent without the use of your calculator. Show your work. 16 to the 1/4 cubed is the 4th root of 16. Then cube it. Let me see. 2 times 2 is 4, times 2 is 8, times 2 is 16. So that means this whole thing is 2. 2 cubed is 8. Okay, I'm going to tell you right now, you better know all the powers of 2, all the way up to 2 to the 10th. And I want you to know them like that. Let's go with the square root of 25, and then cube it. Square root of 25 is 5. 5 times 5 is 25 times 5 is 125. This is going to be a fraction because it has a negative exponent. The cubed root of 8. And then we square it. Cube root of 8 is 2. Squared is 4. Guess what? The next 2 pages are homework. If you have any questions, make sure you ask me in class. See you soon, guys and girls.